Let's see this question. We want to categorize this rational function. So it's called a rational function because the variable appears in the denominator. So if the variable appears in the denominator when x to be a certain value, the denominator will be 0. But in mathematics, the denominator can never be 0, right? This does not exist in mathematics. So in this case, we recognize if x equals to 2 or -2, then square of 2 or -2 is 4. 3 times 4 will be 12. 12 minus 12, that will cause 0 in the denominator. So we will see domain, right, of this function will be 3x squared minus 12, not be 0. Right, solve for this one. The 3x squared not be 12, and divided by 3 on both sides. That means x squared cannot be 4, which means x cannot be 2 or -2. So that's the domain of this function, which means all real values works for this function, but 2 or -2. And because of this, we have two vertical asymptotes. So vertical asymptotes. Asymptotes. So which is x, not, so when we talk about domain, that's x not equal to 2 or -2. But when we talk about vertical asymptotes, that means x equals to 2, x equals to -2. So if we graph the function, so we will get, let's say this is 2. So we 2, this is -2. We will have two vertical asymptotes, which means the function will not pass through these vertical asymptotes. But look, okay, looks like we have two vertical asymptotes, right? So domain is this for sure. X cannot be 2, cannot be -2. And looks like we have two vertical asymptotes. But sometimes if the numerator we can factor out the common factors with the denominator, then we can simplify the function. So let's see if this function can be simplified. So the numerator we see 4 is a common factor. So let's factor out 4. Then we have inside the parentheses, we have x squared minus 4x plus 4. Indeed. And this can be factored as 4 times x minus 2 squared. So the denominator, we can factor out 3. Then we have x squared minus 4. And then x squared minus 4 can be simplified as x plus 2 and x minus 2. So let's rewrite this. So the numerator we can write as 4 times x minus 2 squared, which is x minus 2 times x minus 2. The denominator we can write as x plus 2 times x minus 2. Indeed, we have common factors in the numerator and in the denominator. So those two becomes 1, right? Something divides by itself is just 1. So the function is simplified to be just this part. Just this part. Okay, so which means x equals to 2, because those two simplify to be 1, which means x equals to 2 is not a vertical asymptote, but a removable singularity. Removable singularity. Okay. And then we write as x equals to 2. So x equals -2 is indeed a vertical asymptote, but x equals 2 will only be a circle somewhere. So let's see, where is the circle? Let's see. Okay, so when x equals 2, let's see, x equals 2, we just plug into here, or 2 minus 2, that equals 0. So that means at 2 comma 0, we will have a circle. So right here, we will have a circle. So when the graph goes to this point, because this open circle means void, so the function value is not there, and the 2 is not in the domain of this function, so that causes open circle. But we won't have this vertical asymptote. So because of simplification, this vertical asymptote becomes a removable singularity, which is a circle. All right, now let's see horizontal asymptotes. Right, horizontal actually only one, so asymptote, no S. The degree of the numerator and the denominator are the same, or even we can look at the simplified version. Right? So if the degree of the numerator and the denominator are the same, in this case, it's just 1, degree 1. So the horizontal asymptote is just y equals to the leading coefficient of the numerator divided by the leading coefficient of the denominator. So the y equals to 4/3. So on the graph, if we have 4, let's say this is a 4/3 value. So we will have this horizontal asymptote, which means the graph of this function will never pass this horizontal asymptote. What else? Let's see, x-intercept and y-intercept. X-intercept means the y value is 0. Right? So let's check. So when the y value is 0, we're here. The function value is 0. So that means the numerator is 0. The numerator is 0 means x equals 0. So it's the same, actually the x-intercept is the same as the removable singularity, right? It's right here. It's right here. So let's see y-intercept. Y-intercept means x value equals 0. So we plug in x value to be 0. The numerator will get a 4 times -2. Denominator will get a 3 times +2, right? Because x is 0. Then this two cancel to be -1. So we can get -4/3, -4/3. So the y-intercept, so this is a 4/3, this is a -4/3. So this will be the y-intercept. So we will have a graph, probably something like this. And this side, probably something like this. So that's just one branch of the rational functions. So what else? So we have a domain of vertical asymptotes, removable singularity, horizontal asymptote, and the x-intercept and the y-intercept. So if we do want to graph this one, we can check a couple of values. Let's check f of -3. F of -3. Because we want to find how to graph on this side, on the side of x equals -2. So we plug in 4 times -3 minus 2, 3 times -3 plus 2. So we get -1, -3 for the denominator. The numerator will get -5 times 4, -20. So we get a 20/3 positive value. So -3, 20/3 is about 6.66, goes on forever, right? 6 point. So almost close to 7. So -3, let's see, -3 is about here. X equals -3. Then y value equals the 20 over 3, almost 7. So this is 1 1/4 here. So that's a 4 over 3. So it has to be 5 times. So 5 of this. So if I extend this, so this is 4 over 3, 8 over 3, right? 12 over 3, 18 over 3, and then 20 over 3 somewhere here. So 1 point is somewhere here. Then, so we can evaluate, let's see. Oh, hold on. We have vertical asymptotes here. We have vertical asymptote here. So the graph has to be here. Right, so this is -3 is here. So 20 over 3 is somewhere here. So the graph you can imagine goes here somehow, somewhere like this. So this will go get closer and closer to this asymptotes. And on this side, it gets closer and closer to this asymptotes. Keeps going. And this one, this graph should draw better. So this graph should be somehow like this. Oops. So arrow here, it gets closer to this asymptote, and this side gets closer and closer to that, to this asymptotes. So I have these two pieces. So I guess that's it. But the graph is really bad. So the characteristics are all this.